Hi everyone, today we will discuss multiplication of vectors. So if you consider this multiplication of vectors, so there are two type of multiplication. One is termed as the scalar product or dot product, and another is termed as the cross product or simply the vector product. So we have either the scalar or dot product, either scalar product we say or the dot product, or as far as the other type of product is concerned, that is termed as the cross product or the vector product. So let us discuss one by one. So if you have suppose two vectors, let us say A as well as B, vector A and vector B, and suppose angle between these two vectors, if it is these two vectors, if it is theta, then when we consider the dot product, so that is represented as A dot B, and vector A dot vector B, and this is equal to mod of vector A into mod of vector B and cos theta. Angle between these two vectors, it is theta. Now when we consider the dot product, this is the representation that we do for the dot product or the scalar product. So A dot B, vector A dot vector B, it is equal to magnitude of vector A, magnitude of vector B and cos theta. This mod of A, mod of B, it can also be represented as simply A and B. If you write A and B without putting this notation here, so that also represents the magnitude of vector A or magnitude of vector B. And we have just removed vector notation from this. So if there is no vector notation, it means we are just talking of the magnitude of that vector. So here this can also be represented as vector A dot vector B is equal to simply AB cos theta. AB cos theta. I have not used this mod sign because I have removed this vector notation, and if you want to use the vector notation at the same time, if you want to consider just the magnitude part of it, then you have to put this mod sign here. So mod of A, mod of B cos theta. Now here you can see mod of A, this is a scalar quantity, mod of B, it is also a scalar quantity, and theta or cos theta, as far as the angles are concerned, that is also a scalar quantity. So this dot product, it is always a scalar quantity. It means when we consider A dot B, so the outcome, it will always be a scalar quantity. So it is not a vector quantity. So after the dot product of two vectors, we get a third quantity which is scalar in nature. It is not vector in nature. So this way we can calculate this A dot B. Now if you see some property of this, then A dot B, it is equal to B dot A. Vector A dot B, it is equal to vector B, because there is no problem as far as the direction is concerned. So whether we say A dot B or whether we say B dot A, so it remains same. So A dot B, it is equal to B dot A. This is also termed as commutative law. Now here if you consider this distributive law, A dot vector B plus C. So one by one you can have this dot product. So A dot B plus this A dot C. So plus A dot C. So that is termed as your distributive law. Now here the scalar product of two mutually perpendicular vector is 0. That you can understand. Two mutually perpendicular vector. If suppose this is your vector A and this is vector B, angle between them it is 90 degree. Okay, so if we consider, let us say vector A along x-axis, vector B along y-axis, and x and y are at 90 degrees, so obviously angle between these two vectors here also it is 90. Cos 90 is how much? 0. So cos 90 is 0. So here you can write vector A dot vector B is equal to AB cos theta. Theta here is how much? 90. Cos 90 it is 0. So this will become 0. So that's why we say vector product of two mutually perpendicular vector, it is always 0, just because theta is 90, cos 90 it is 0. So finally we get that result. A dot A, it is equal to A square. A dot A, again if you say, so A into A cos theta, and angle between A and A, it will be how much? 0. So cos 0 is how much? 1. So that becomes A 1, so A into A, that is A square. So we say A dot A, it is equal to A square, because angle between these two vectors, because it is same vector, so that will be 0. Now let us consider the vector product. So if you consider the vector product, so again if you take suppose two vectors, vector A as well as vector B, and again we are assuming the angle between the vectors A and B theta, angle between vectors A and B theta, then again vector product, it is also termed as the cross product, and we represent it with the multiplication notation. So you can say A cross vector A cross vector B, that is again equal to your mod of A mod of B sine theta. But A cross B, it is a vector quantity. The outcome of A cross B, it will be a vector quantity. So let us say it is equal to C. So vector C, A cross B, as we have seen, A dot B is a scalar quantity, but here A cross B, it is a vector quantity. Suppose it is equal to C, then C is equal to mod of A mod of B sine theta. But here when we consider mod of A mod of B sine theta, all these three are scalar quantity. So this does not justify that C is a vector quantity. So just to justify that C should be a vector quantity, we will put a unit vector N here. So this makes this representation as a vector representation or a vector quantity. It means magnitude of the vector C, C is the outcome of these two cross product of these two vectors A and B. So vector C is equal to vector A cross vector B. Magnitude of that, it is equal to mod of A into mod of B into sine theta. The direction of this vector C, it is represented by this unit vector N. Now the unit vector this N, it is just a symbolic representation, is such that C is perpendicular to A as well as perpendicular to B. The outcome of the cross product of these two vectors, or the vector product of these two vectors A and B, that is A cross B, it is suppose C, the direction of C is such that it is perpendicular to vector A as well as perpendicular to vector B. So let us just take an example to understand. Suppose your vector A is along this line and vector B is along this line. Okay, these are the two different directions. It can be at any angle theta, it can be mutually perpendicular or any other angle. So let us say A is along this and B is along this. So C is A cross B. So that C should be such that it is perpendicular to A as well as perpendicular to B. So what is perpendicular to this line and this line? So this is perpendicular to this line. This line is perpendicular to this surface, and this surface means this line as well as this line. So this third vector C, which is outcome of A cross B, that will be perpendicular to this line as well as this line. So you have this. Now perpendicular, so either this line is going into the plane or it is going out of the plane. So depending on that, again we will define whether this line, we will consider the direction of C going into the plane or it is going out of the plane. So if it is going into the plane, that will be taken as a negative. If it is going out of the plane, that will be taken as positive. So that again we will discuss how this positive or negative or into the plane and out of the plane, it can be considered. So we have this vector C such that C is equal to A cross B, that is mod of A mod of B sine theta, and the unit vector N. This unit vector N represents the direction of this vector C such that C is perpendicular to A as well as B. Now just to define this, we can consider this screw rule. Now if you rotate a screw in the clockwise direction, what do you observe? It goes inside the plane. If we rotate it like this in the clockwise direction, it will go into the plane, it penetrates into the plane. And if we rotate it in the anti-clockwise direction, it comes out. It comes out. A nail, if we take example of a screw or a nail, then if we rotate it like this rotation means what? The clockwise rotation. So if you rotate it like this, it will penetrate and it will go into this surface or into this plane. And if we rotate it like this in the anti-clockwise direction, then it comes out. So when it comes out of the surface, it is taken as positive. When it goes into the surface, it is taken as negative. So here you can see, if we rotate it in this direction, you can see this direction means the anti-clockwise direction. It will be moving up. Okay, yani out of the plane. And here, if we rotate it in the other direction, it will go into the surface. Going into the surface, we consider along negative of z axis, so it is with the minus sign. Coming out of the surface, it is taken with respect to z axis. If you analyze, it means it is along the positive of z axis when it is coming out. So it means anti-clockwise rotation, that gives you positive of z. Clockwise rotation, it gives you into the plane, and it is going down into the plane. If it is going into the plane, that will be taken with the negative sign. If it is coming out of the plane, that is taken with the positive sign. So that is when we consider this right hand and we consider the screw rule. This is termed as the screw rule. So based on that, you can define the cross product C is equal to A cross B. So the direction of C will be either into the plane or it is out of the plane, whether this A and B. When we say A cross B, that means it is from A towards B. So if this is your suppose A and this is vector B, so from A towards B at an angle of this theta, it means we are moving in which direction? We are moving in the anti-clockwise direction. It means here C will be positive, and C positive, when we say C positive, it means it is out of the plane. If you consider B cross A, so B cross A means in which direction? In the clock, from B towards A. A cross B is different from B cross A. A dot B is same as B dot A, because we don't have any problem regarding the direction of the vectors, because A dot B itself is a scalar quantity, but A cross B, it is a vector quantity. So there will be difference here. A cross B means from A towards B. So from, if you represent this as A and this as B, means from A towards B. This is your A, this is B, and this is the outcome C. Because this is along the z axis, this is suppose your x axis, this is z axis, and then perpendicular to this line another, it will be your y axis. This guy, you can take this surface, you can see this surface. So if you observe this surface, so this line is along x axis, this line it will be along y axis, then perpendicular to this surface it will be along the z axis, just like this, perpendicular to this surface, either into the plane or it is out of the plane. So when we say A cross B, from A towards B, and from A towards B we are moving in which direction? Anti-clockwise. So C will be positive, and that will be towards the positive x-axis. If you say B cross A means from B towards A, so it means we are moving in the clockwise direction, so C will be negative and that will be into the plane. So this is the significance of A cross B and B cross A. That's why we say A cross B is not equal to B cross A, because even though the magnitude of A cross B and B cross A, it will be same, the directions will be opposite, and as far as the vectors are concerned, when magnitude and direction it is same, then only we say that they are equal vectors, otherwise they are considered as different vector. So here you can see A cross B, it is equal to minus of B cross A, and here you can say A cross B is not equal to B cross A. A cross B is not equal to B cross A because there is a change in direction, even though the magnitude will be same, but there is a change in direction. So we say A cross B is not equal to B cross A. So here you can see A cross B is equal to, we have put this minus sign here. So A cross B is equal to minus of B cross A because of the change of direction. Similarly, you can consider A cross B plus C, vector B plus C, it is equal to again A cross B plus A cross C, and A cross B up plus this A cross C. The vector product of two parallel or anti-parallel vectors, that is A cross B, it is 0. What is this parallel or anti-parallel? Let us say this is your vector A, and again you can consider this is a vector A. Direction of this and this it is same because they are along the same line. Length of this part and this part, if it is same, if it is taken as same, then the magnitude of this and this, it is same. When we say this length of this or length of this, it means we are talking of the magnitude of this vector as well as magnitude of this vector. So if magnitude is same and the direction is also same, it means between these two vectors angle becomes what? 0. So A cross A, it will be how much? Mod of A sine theta and unit vector. Sine theta, it will be how much? 0, because theta is 0. So that's why we say A cross A, it is equal to 0. So whether you take this parallel, and anti-parallel means if you take this vector A like this and suppose you have another vector. So here suppose this is your vector B. Now again direction of A and B, it is different, but they are along the same line. It means we will call it as anti-parallel vectors, or you can also consider this way and this way. This is your vector A and this is vector. These two are parallel to each other, but they are oppositely directed. So when they are oppositely directed, it means we will call it as anti-parallel vector. If suppose this is your vector A and this is vector B, it means here they are parallel and they are in the same direction, so they will be termed as parallel vector. Now length of this and this, if it is same, it means magnitudes are also same. In that case we can say B is equal to this A, because direction is same and magnitude is also same. Here in this case, if B is equal to A, so magnitude is same but direction is opposite to each other, so that will be considered as the anti-parallel vector. So in that case theta is equal to how much? 180 degree. So sine 0 or sine 180, that will be same, and that is equal to 0. So from there we get this A cross A, it is equal to 0. Now whatever we have learnt as far as the dot product of vectors A and B is concerned, or cross product of A and B is concerned, using that concept we can consider the dot or cross product of the unit vectors. When we say unit vectors, so you have this unit vectors I, J as well as K. Now magnitude of all these vectors, it is 1. That is already known to us, that the magnitude of vector I, magnitude of vector J, magnitude of vector K, because they are unit vector, it is equal to 1. Now let us see what happens. I dot I means what? Mod of I cos theta. Angle between again I and I, that is same vector, it will be how much? 0. So cos 0, it is 1. So mod of I and 1, mod of I 1, cos 0, that is again 1. So this will be equal to how much? 1. So I dot I is 1, J dot J is also 1. We use the same logic. K dot K, it is also 1. I dot J, angle between I and J, because I is along x axis and J is along y axis. It means angle between these two unit vectors is how much? 90 degree. Cos 90, it is 0. So mod of I, mod of J cos 90. Cos 90 makes it 0, so that it becomes 0. Similarly, I dot K, K dot I, and that is also 0. So I dot J, J dot I dot K, or K dot I, because A dot B, it is equal to B dot A. So similarly, we have these relations. So all these are 0. Similarly, J dot K, K dot J, that will be same, and this is also 0. Now let us come to the cross product. So I cross I. So mod of I sine theta, again the unit vector this time. So in that case mod of I sine theta. Here again angle between I and I is what? 0. Sine 0, it is 0. So that is equal to 0. So I cross I, that is equal to J cross J, that is equal to K cross K, it is 0, just because sine 0, it is 0. I cross J, it is equal to K, because I is along x axis, J is along what? Y axis. So it will be mod of I, mod of J sine 90 and the unit vector, and that unit vector should be such that it should be perpendicular to I as well as perpendicular to J. So what is that quantity which is perpendicular to I and J? And that is your unit vector K. So this is equal to unit vector K. Similarly, J cross I, it will be minus K, because there is again change in direction. I cross J is minus of J cross I. So on that basis we can have this relation. I cross K, it is minus of J. K cross I, it will be J. Similarly, J cross K, it is I, and K cross J, it is minus of I. So that you can understand. So these are just based on the properties of the dot product as well as the cross product. Here we have these vector product of unit vector, whether it is a scalar product or cross product. Magnitudes of these unit vectors are 1 cos theta or sin theta, depending on theta it will be either 0, it will be 1. So we have all these values. Now if you consider the vectors in the form of position vector, then how we use the dot product or the cross product. So if you take this vector A, it is equal to, suppose, a1i plus this a2j plus a3k. This is the position vector of this vector A. So we write in this way, a1i plus a2j plus a3k. Similarly, suppose you have position vector B. So that will be your b1i plus b2j and plus b3k. Now if we use the, because we have till now we have learned there are vectors A and B and an angle between them it is theta. So either it is AB cos theta, AB sin theta, depending on whether we are considering dot product or cross product. But here the vectors are given in terms of the position vector, then how to multiply it. So here A is equal to a1i plus a2j plus a3k, B is equal to b1i plus b2j plus b3k. So A dot B, it will be I dot I, it is equal to how much? 1. So a1 b1. Now if you multiply this with this, so I dot j, each and every term it will be multiplied as we do in normal algebraic multiplication. But I dot j, that makes it 0, I dot k it also 0, j dot I it will be 0, so all other terms it will vanish. Only I dot I it is 1, so that will remain a1 b1, j dot j that is also 1, so a2 b2, a3 b3. Other terms are not appearing here just because I dot j or j dot k or k dot I, though they are all 0, so that eliminates all those things. So simply you will get this relation. So you have to consider only this as well as this. Remaining you need not worry because they take care of themselves, because that becomes 0 because it is the outcome of I dot j, I dot k, k dot j and so on. Similarly, if you consider a plus b whole square, so it is a plus b dot a plus b. A plus b whole square means a plus b dot a plus b, and if you consider this, so it will be again a square plus b square plus twice of a dot b, because a and b are vectors. So when we say a plus b dot a plus b, so again there a dot b will come. Now if angle between a and b it is theta, then we will write it as mod of a mod of b cos theta and so on. Now if you consider the cross product, so if we consider A is equal to a1i plus a2j plus a3k and B is equal to b1i plus b2j plus b3k, then just to remember this, use the concept of the determinant. So A cross B, write the unit vector in the first row, that is I, j and k. And below this first row, you write their coefficients. So coefficient of I here it is a1, here it is b1. So a1, b1. Coefficient of j here it is a2, here it is b2, a3 and b3. So we have a2, b2 and a3, b3. So this becomes your A cross B. So I, j, k, either you can write in the first row or you can write in the first column, and accordingly you can arrange other terms in the next columns. So I, j, k, a1, b1, a2, b2, a3, b3. Now you know how to simplify this determinant, expand it and get the value of this A cross B. Now we can just some uses of these vector product we can consider. If you consider this moment this tau, that is equal to r cross f, where r is the position vector and f is the applied force. F is the applied force, r is the position vector, then the moment it is given as r cross f, that is the cross product of the position vector and the applied force f. Similarly, the linear velocity v, it is equal to omega cross r. Again, omega is the rotational or angular velocity, r is again the position vector, so v is equal to omega we generally say omega into r, but actually it is omega cross r. So V is equal to omega cross r, and the angular momentum, that is L, is equal to, angular momentum is represented as L, so L is equal to r cross p. R is again the position vector, p is the linear momentum, so r cross b. So it is the cross product of the position vector as well as the linear momentum. So here you have r m cross b. M, it is a scalar quantity, we can take this out, and so that it is m r cross this v. So we have this relation. Okay, so it is m r cross v. It should be equal to your m r cross v. Okay. So these are some of the physical quantities, and when we use this vector product, particularly the cross product, we have certain relation. So these things again in detail we will discuss when we consider the physics classes. So during the physics classes, chapter by chapter, we will discuss all these things and it will be elaborated. For the time being, you can understand that moment tau it is equal to r cross f, linear velocity v it is equal to omega cross r, angular momentum L it is r cross p. P is the linear momentum, that is mv. M is a scalar quantity, it can be taken out, so that it is position vector r cross v. So we have these relations. So I hope you have understood all this, and we will take up examples based on the dot product as well as more and more example on this vector based on other concepts like addition, subtraction and all other concepts of vector. Thank you.